class. So now, let's proceed on our abelian group. So abelian group, a group set of ordered pairs A is comma star is said to be abelian if a binary operation is commutative. A star B is equals to B star A. Note, given group set of A comma star, if A is finite, then the order of the group denoted by G is the number of elements of G. We have also the properties to be considered if we need to prove that it is abelian. So we have associative, identity, inverse, and commutative. So in associative, we have A star, quantity of B star C is equals to quantity of A star B and star C. So for all A, B, C is an element of G. So identity, A star E is equals to E star A is equals to A. So inverse, if there exists an element of G for every A is an element of G such that A inverse star A is equals to A star A is equals to E. So commutative, A star B is equals to B star A. So let star be defined on Z as A star B is equals to A plus B plus 1. So for all A comma B, so is an element of Z. Show that Z comma star is an abelian group. We need to prove that it is an abelian group. So given by the definition, or we know that the procedure of proving if it is a abelian group. So we need to prove also if it is closed, associative, identity, inverse, and commutative. Let's prove that star be defined on Z is our integer as A star B is equals to A plus B plus 1. So first, we need to prove if it is closed. So by the definition, if we add A and B, the result is also an integer. So A plus B plus 1 is an element of also of an integer. So what is the A plus B plus 1? So that is A star B. So A star B is an element of Z. So A star B is an element of Z. Therefore, Z comma star is closed. So that it is closed. So next, we need to prove that it is associative. So letter B. So in our associative, we have A star B star C is equals to A star B star C. First term A plus B plus 1 star C is equals to A star, so B plus C plus 1. So A plus B plus 1 plus C plus 1 is equals to A plus B plus C plus 1 plus 1. So now, we are going to combine the like terms. So, 1 plus 1 is equals to 2. A plus B plus C plus 2 is equals to A plus B plus C plus 2. So now, it's satisfied that Z, comma, star, so that it is associative. So we need to prove also if it is identity. Identity property, we have A star E is equals to A. So let's apply the definition of identity given this problem. So A star B is equals to A plus B plus 1. So A plus E plus 1. So is equals to A. So we need to cancel A, negative 1. So therefore, identity element exists. So, next, we need to prove also the inverse element, if it is inverse. A star A inverse E. So let's apply also the definition. So A plus B, which is A plus B plus 1. So A inverse of A plus 1 is equals to negative 1. A is negative A to 2. So A plus A inverse plus 1 is equals to negative 1. So we need to transpose A here. So it will become negative A. So by 1, we need to also transpose here. So negative 1, negative 2 is negative 2. So A inverse is equals to negative A, negative 2. So we prove that inverse element exists. Now, let's proceed on our commutative property. So A star B is equals to B star A. It is just a formality. So A plus B plus 1 is equals to B plus A plus 1. So, we prove that it is a commutative. So Z star or integer comma star is an abelian group because we prove that it is closed, it is associative, it is identity, element, inverse element, and commutative. Let's have an exercises. The letter A will be answered by Miss Mel, letter B will be answered by Miss Jenny, letter C by Miss and letter D will be answered by Miss Kim. Now, let's check if your answer is correct. So, in our letter A, is star associative under R positive? So, we test for associativity. So, if for all A, B, C is an element of R. So, A, for associative, we prove that it is associative. So, A star B is equals to 1 plus B plus A. So, we come up with A plus B plus C plus 2. So, is equals to A plus B plus C plus 2. Is there an identity element on star? Yes, there is. So, we test for the existence of E where E is an element of R. So, E is equals to negative 1. So, is there an inverse element for every element on R positive? We test for the existence of A, where A inverse is an element of R. So, A inverse is equals to negative A, negative 1. Then, it's not an element of R positive. Is star commutative? Yes, it is commutative. So, just a formality, it is a commutative. So, A plus B plus 1 is equals to A plus B plus 1 also. Commutative. So, since R star is associative, has identity, an identity, E, has an inverse A, for every A is an element of R, and commutative, so star is abelian.